write this down and take a little note. Basically, children, direct variation is pretty much as it sounds. When things directly vary, pretty much the way to think about it is like this. First of all, it's really, for all intents and purposes, the same thing as being proportional. Okay, or as one thing goes up, comma, so does the other. For example, if you're driving down the road at, let's say, 50 miles per hour, where x is how many hours, and y is how many miles you go, okay? If you're driving at 50 miles per hour, and you're driving for 0 hours, how far will you go at 50 miles per hour? Madison, it's a tough one. 0 miles. If you drive for 1 hour, you're going to travel how far? Brocala. Very good. What if you're driving for 6 hours? David? 300 miles. And if you drive for 8 hours, you're going to go 400 miles. Notice, as the time goes up, so does the distance you travel. Okay? Not only does it go up, but it goes up at the same rate, which means it's proportional. And they have, well, they write it out like this. If you want the direct variation equation, it looks like this. Y equals k times x. Which is this, children? Don't let all these goofy letters and numbers fool you. The letter k is your, what we call the constant of proportionality. Which simply means, what do you multiply x by to get y? Over here, my constant of proportionality was 50. You know, if you have a job where you make $7 per hour, what do you think your constant of proportionality will be, Alex? $7, because if you're making a table out of that, you know, you work for 5 hours, you're going to get paid $35. You work for 2 hours, you're going to make $14. You work for 0 hours, you're going to get paid $0. Now, not all things do vary directly. There's what's called inverse variation. You don't have to write this down. But there are some things that, as one goes up, the other one goes down. Anybody think of anything right offhand? Here would be an example. The number of miles you travel would vary inversely with the amount of gas in your tank. Correct? You know, you drive 50 miles, you might start out with 100 gallons in your tank, but as you go 70 miles, maybe you've only got 60 gallons in your tank. Or wait, did I say 50? 30, whatever. The farther you go, the fewer gallons you're... Is it less or fewer? You can count gallons, right? So it would be fewer gallons in your tank. Other things that vary, as one goes up, the other goes down. That's right. The more you buy, let's say you're buying golf balls, okay, the more golf balls you buy, the less money you're going to have. I mean, that would vary over there. But anyways, back to this. If they ever ask you for the constant of proportionality, all you have to do is look at the table you're given. Let me see. Maybe we should do one here. Well, here, write these down. Let's take a look at this. Going back to this one, sorry. Was this it? Make sure that you know, in order for something to be direct variation, it has to be that whole proportional thing. And remember, two things had to happen for something to be proportional. When you graph it, it has to go through the origin. And it has to have this constant of proportionality, which is what we just talked about. Okay, those two things have to happen. When you graph it, if I were graphing these things here, it has to go through the origin. You know, this one would look like this. This one here, not quite as steep because it's times 7. Probably go like that. Going through the origin. Take a look at this. Let's look at this. If you have the area of a square, anybody know what the formula for the area of a square is? Maggie? Well, square, let's call squares have all equal sides, so it's going to be, yeah, area of a square is s squared, right? Or if I change it, let's use y's and x's. Y equals x squared. Do you think this is proportional or direct variation? Well, let's look and see. If I make a table of this, if x is 0, what's y? 0. If x is 1, what's 1 squared? 1. If x is 2, what's 2 squared? If x is 3, what's y? 9. Is this direct variation? Because as one goes up, the other one does go up. But what would be the constant of proportionality? Is that my phone button? It sounds like it's coming off the wall. Does this have a constant of proportionality, Alex?
No.
It does not. Okay, this is not direct variation. It does fit this requirement, but it doesn't have a constant of variation. As a matter of fact, if you graph this, you know what it looks like? It starts here. 1, 1 starts here, but 2, 4 ends up going like this. 3, 9 ends up looking like this. 4, 16. It's a little curved, a little thing that shoots up like that. If you're graphing it, it's not a straight line. And proportional things have to be straight lines. What about this one? What about the perimeter of a square? Perimeter of a square, the formula for perimeter of a square would be what? Rather than saying s plus s plus s plus s, it would be, Brooke? 4 times every side. And if you do this out in table form, you end up with 0, 0, 1, 4, 2, 8, 6, 24. Is this direct variation, yes or no? It does go through 0, 0. Is there the same constant between everything? Do you multiply this by the same number every time you get y? Yes. So this is, yes, direct variation. Direct variation. I don't know if there's anything more to tell you about that. It just seems to be kind of fun. Look at page 467, would you please, with me just really quickly here.